Audio Jungle. Audio Jungle.
Hello everyone, myself Singh Maurya, and hope you all are doing well. Guys, now today we have to solve that GATE 2018 performance problems, right? So check. This is question number 4. This is MCQ basically. What it is said: a jet aircraft is initially flying steady and level at its maximum endurance condition. Okay, this aircraft is what? Flying at a steady level and maximum endurance condition. What is the mean of maximum endurance for the jet? For the jet, maximum endurance means minimum power condition. Okay, please make a note: minimum power condition. Minimum power condition. All right. Now, so for the aircraft, fly steady and level but faster at the same altitude. So altitude must be same, but like this should be faster. The same aircraft, it should be faster. Okay, this is the V2. Okay, this diagram, let me correct. All right, so this V2 should be higher than V1 for same altitude. Okay, how it is possible? Okay, so now what pilots should do? So option they have given: increase thrust alone, increase thrust and increase angle of attack, increase thrust and reduce angle of attack, reduce angle of attack only. So if you want to increase speed, if you want to increase the speed of the aircraft, okay, speed of aircraft, you can increase, you can increase, you can increase by increasing, by increasing thrust. That is true, no doubt, but you have to maintain it at a same level, huh? It should be on same level, because if you increase the speed of the aircraft by increasing the thrust, means throttle, you will provide more throttling to the engine, so thrust will be increasing. So obviously that time aircraft will be accelerating. Okay, once you increase the thrust, aircraft will be accelerating, but you have to maintain the aircraft at the same level. So if you increase the speed of the aircraft by increasing the thrust, then that time it will try to climb. That will come for the climbing condition. So climbing means it will be gaining the altitude, so it will not be a same or steady level condition. So that what you will do, that aircraft should not go for next another altitude, it should be on the same altitude, means it should be on the same level. So for that reason what you will do, you will reduce the angle of attack, you will reduce the angle of attack. So only saying increasing thrust is not correct. Okay, and increasing thrust and increasing angle of attack 100% it is wrong, because if you increase the thrust, so speed will be increasing, that is true, but at that time that aircraft will go for the climbing, means it will be increasing the gaining the altitude also, when angle of attack is also increasing. So but you don't want to go for next another level or next another altitude. So what you will do, you will increase the thrust and at the same time you will reduce the angle of attack. So this one is correct answer, reducing angle of attack only, this is 100% wrong. So now in this case, if you want to increase, because if it is going for the maximum endurance condition, so that will be the minimum power condition. Okay, and now you are going for the another speed, now you want to increase the speed, so definitely that speed will be increasing once you increase the thrust, no doubt, but in that condition you have to decrease the angle of attack, otherwise it will go for the climbing condition. Okay, so what is the correct answer for this question? Answer will be C. Hope you understood. Okay, if any doubt you may have, you write comment in comment box, so definitely I will reply for that. All right, now we'll go for next question. So see, this is the question number 38, right? Again, all the questions whatever the question we are solving today, all question asked in GIT 2018. Okay, so now see what is the given condition. ISA, international standard atmosphere condition, it is given. So uh, at ISA, I will write at ISA. Okay, what is the temperature? Sea level obviously T naught 288.16 Kelvin, density rho naught 1.225 kg per meter cube, G it is 9.81 meter per second square, 287 kg Kelvin. The density of air at Leh, which is at altitude. Okay, this question is very simple. The thing is, like, if you read this problem simply, they have given all the data at sea level condition, like temperature they have given, density they have given, G value they have given, R value they have given to you, and now they are asking the density of air at Leh, okay, which is at an altitude of 3500 meter above the sea level. So this question is, now what you have to do, see, this is basically, this is the sea level here. Okay, this is the sea level, I must say this is the sea level, and this is the another altitude, Leh. Okay, and it is at the altitude 3500 meter. Okay, so I must say at sea level I must say at sea level, uh, temperature will be T naught, density will be rho naught, pressure will be P naught if it is required. Okay, if it is required, if it is not required, it's okay. And at 3500 meter altitude, temperature will be TH, density will be rho H, and pressure will be pH. Okay, guys, make a note of it. From sea level to 11 kilometer, from sea level to 11 kilometer, it is called troposphere. What it is called? Troposphere. And in the troposphere, lapse rate, you make a note because this is another question. Lapse rate, what is the lapse rate? Lapse rate meaning is temperature changing with respect to altitude. That value will be given by lambda, and that value is nothing but 0.0065 Kelvin per meter. Means from the sea level, to any altitude in upward direction, if you are going, okay, then temperature will be decreasing by this rate, I mean 0.0065 Kelvin per meter, or you can write 6.5 Kelvin per kilometer. Okay, this is the very important value. You please make a note of it. 2 points I have given, both points are very important. All right, so now they are asking the density value. Density here they are asking at 3005 meter altitude above mean sea level. So what we'll do, I will give the formula for troposphere. Write the formula for troposphere, which is 0 to 11 kilometer. Above that stratosphere come. So first formula is what? For temperature. I mean, if you want to calculate temperature at any altitude, then formula will be T naught minus lambda h. Like here T naught is given, how much it is given? It is given 288.16. So 288.16 minus lapse rate, I told you 0.0065 Kelvin per meter, and how much meter it is? H, it is 3500 meter. So now you can calculate temperature at 3500 meter, which is nothing but TH. Okay, what is the value you may get at this altitude? What value you may get if I will calculate? Then 288.16 minus 0.0065 into 3500, it is approximate to 265.41 Kelvin. This is the value. Temperature formula you need to remember. Okay, second, you need to remember the density formula. So density at at any altitude divided by density at sea level is equal to temperature at that altitude divided by sea level to whole power g by, this is g, okay, lambda r minus 1. So you can write TH, what value you got here? 265.41 divided by what is the sea level temperature? It is 288.16 to whole power g, 9.8 it is given, divided by lambda 0.0065 into 287 minus 1. So rho h means rho at 3500 meter is equal to rho naught. You just multiply rho naught. Sea level rho naught is given, how much it is? 1.225. So it is nothing but 1.225 into 265.41 divided by 280.16. If you solve this value, it will come approximate to 5.25 minus 1. So rho h you can calculate. Let me calculate this. This is 21.225 into 265.41 divided by 288.16 to whole power 5.25 minus 1, it is 4.25. So if you do this calculation, so this is nothing but 0.863 kg per meter cube. This is the answer. This is answer. So this is the fill in the blank. So what is the answer? 0.8636 unit is kg per meter cube. So only value you have to give. Okay, so two formula I have given. Third formula is pressure. So all three formula you must know. Okay, anything they can ask. Again, that pressure at any altitude, if you want to calculate pH by P naught, it will be TH by T naught to whole power g by lambda. See, g by lambda r you can calculate separately. Okay, g is nothing but 9.8, lambda is 0.0065 into r, 287 it is given. If you calculate g by lambda r, you may get 5.25. So this is the third formula. So all three formula are very important. Okay, even here you have calculated your answer you got here. This was the second formula and this was the third formula. Okay, temperature 1 2 3, I must say temperature calculation in troposphere, density calculation in troposphere, and pressure calculation in troposphere. That formula you must know. Okay, this is the derived formula. I mean, you can derive it also, but here it is not required. But just you remember the formula, all three formula. If you remember any problem, if from atmosphere comes, then definitely you will able to solve. All right. Now we'll go for next problem. Check. This is the next problem. Again, it is from GATE 2018. Okay. This is problem number 40. Check. Check there. The aircraft mass is given. How much it is? Mass is equal to 400,000 or 400 into 10 to the power 3 kg, you just say. Okay. Right. Cruises at 240 meter per second. That velocity is given. How much? 240 meter per second. At altitude of h is given. How much? 10 kilometer. Its lift to drag ratio. All right. Lift to drag ratio also given. How much? 15. Assuming z 9.81 meter per second square. The power in megawatt needed for its cruise. See, megawatt unit. So whatever the value here you have to fill, that should be in megawatt. Power must be in megawatt. That's the reason I said to you many times, whatever fill in the blank type question suppose comes in examination, so very careful about the unit of that. Okay, whatever the question will be asked, for that you have to check units 2 times at least. All right, now see, so we'll go for the calculation. Simple. See this problem, what they are asking, what is the power required. Power needed means power required they are asking for its cruise. So suppose this is what sea level. Okay, this is what sea level condition, and here that aircraft is what flying. Okay, so for this aircraft you need to calculate what is the power required. Power needed means power required. What will be the power required? What will be the power required? Definitely whatever the power required, it totally depends on the drag. Yes or no? And it is at what altitude? It is 10 kilometer altitude. So what is the power required? Simple. Power needed or power required, meaning is same. Okay, power required, P is nothing but P, power required, hence PR is nothing but drag. Okay, drag into velocity. I mean whatever the drag based on power required. If aircraft is small, so drag will be small, so power required to propel the aircraft will be small. If a very big size aircraft is there, so drag will be more. Obviously weight will also be more. So weight and drag will be more for the large aircraft. So drag is more, it means to propel that aircraft you need more power, so power required will be more. So hope you understood. Your power is nothing but basically force into velocity, that you know, very basic 6th or 9th standard physics you may have heard that power is nothing but force into velocity. All right. So what force required, lift force or drag force? So obviously drag force, because drag is the one opposition force. Because of the drag only you are burning fuel. Okay, you are burning fuel to get thrust, you are burning fuel to get power, huh? Because of the drag, because drag is the enemy for your aircraft. All right, just like a friction. Okay, so power required is nothing but drag into velocity. So now your job is to calculate drag first. If you know drag, then automatically you can calculate the value. So how to get the drag? So see this ratio they have given, L by D value they have given. So from here drag you can calculate, but you should know what is the lift. Okay, if you lift you know, then automatically you can calculate the value of a drag force. Okay, so how you can get lift force, so that see, uh, density they have not given, even though density is not required also, but if you want to calculate density you can calculate at 10 kilometer. Okay, that also you can do, but here it is not required because it is cruising condition, right? So cruise condition is what always at uh, steady level condition, huh? So cruising is nothing but it's a cruising case. Okay, cruising, it's a cruising condition. Okay, so for the cruising flight you can mention it is the steady level flight. So steady level flight, you know, lift is equal to weight. Yes or no? So what is the weight? Weight is nothing but mass into gravitational acceleration. What is the mass here? It is given 400 into 10 to the power 3. And G value obviously it is given 9.8. That's the reason G value they have given to you. So that you can apply basic formula 9.8. Yes or no? 9.81, sorry, 9.81. So if you do calculation, how much you may get? You will get 3924 into 10 to the power 3 Newton. Okay, now L by D, how much it is given? It is given, let me check. It is 15. So what will be the drag force? It will be L by 15. Same value you can keep in calculator. It is nothing but 261.6 into 10 power 3 Newton. Okay. Now power required you can calculate. Power needed, no? Or power required means PR, drag into velocity. How much it is? They are asking in megawatt, no? Okay. So we'll write this. It is nothing but it is coming 62.784 megawatt. So you have to write value here 62.784. Here you can write 62.784 megawatt. That value you have to keep. That's all. Done. This problem is done now. Again I'm saying, if any doubt or at any steps you are getting problem, you are facing problem, you are not able to understand, you want more explanation, so please write comment on comment box. I will see the message and I will reply for it. Okay, we'll go for next problem here. Okay, this is problem number 42. Check. An aircraft with gross weight of 2000 kg, gross weight. So sorry, kg is given, it means it is mass, no? They have mentioned weight, but unit is kg, so be careful. Sorry. Okay, so they have given mass, how much? 2000 kg. All right. Has a speed of 130 meter per second, a speed of 130 meter per second, where the conditions are atmosphere. Okay, pressure it is given 1 atm, temperature it is given 288 Kelvin, and density it is given 1.23 kg per meter cube. The speed in meter per second required for the aircraft and at an altitude. Okay, all right. So suppose this is the condition, one condition. Here it is not mentioned where the conditions are they have given. So anyway, this condition you can consider at any point, but yes, another condition they have given, that aircraft is what, flying at 9,000 meter altitude. Okay, all right. So this aircraft is what, flying at altitude, and that altitude is nothing but it is given how much? It is 9,000 meter. 9,000 meter, all right. And here they have given all value. This is the one condition it is given. It is not mentioned, but one atmosphere, it is sea level actually. This is the sea level condition, 288 temperature, and density 1225, round of 1.23. Yes or no? So this is the sea level. So this is the sea level value they have given to you. Okay, sea level, and at 9,000 meter, that value again they have given how much? Conditions, that atmospheric pressure it is given 0.31 atm, density how much? Sorry, temperature how much? It is 230 Kelvin, and what is the density at that altitude? 0.47 kg per meter cube. So at sea level, for this particular density, what this speed is given. So this speed is nothing but equivalent air speed. Many times I told, at sea level density is what used somewhere to calculate the velocity. It means it is equivalent speed, simple. And at any altitude, if this density will be used at any altitude, then whatever the speed you may calculate, that speed will be true air speed. So here they have not mentioned the true air speed and equivalent air speed, but yes, that meaning is what the same. I mean, at 9,000 meter, whatever the speed you may calculate, it will be, because density you are using 0.547, it means whatever the speed you may get, it will be true air speed. And at sea level, whatever the density is given, for that particular density, if you have calculated speed, then that speed will be equivalent air speed. And obviously that aircraft is what, flying at this particular altitude and for this density, so whatever the speed is calculated, it is related to this density, hence it is equivalent air speed. And at 9,000 meter, at this altitude, whatever the density 0.547 is given, 0.47 kg per meter cube, with respect to this density, whatever the speed will be calculated, it will be true air speed. I hope you understood that concept, right? Because till now we have solved 2-3 problems based on true air speed and equivalent air speed. Now the same concept you have to apply. What is the concept? Dynamic pressure, you make it same. Dynamic pressure, okay, you make it equal. Dynamic pressure must be same. So you can write 1/2 rho at sea level, okay, So at sea level, what will be the speed? Equivalent air speed 1 by 2 at altitude, that is 9,000 meter, into that velocity will be true airspeed velocity. So at this altitude, at 9,000 meter altitude velocity they are asking, it means they are asking VTAS. What will be VTAS? Check, 1 by 2, 1 by 2 cancel out. So it will be VEAS root sea level divided by this density. What is the equivalent airspeed? Here it is given. Let me check. It is nothing but 130, no? 130. So it is 130 and root, what is the sea level density? I think 1.23 and 0.47. Okay, so your true airspeed, or you can say speed at 9,000 meter must be. Let me calculate this value. So you will get 210.303 meter per second. This will be the answer. Check, this is the fill in the blank or what? Yes, fill in the blank. So it is nothing but 210.303. 210.303. Okay, it is in meter per second, already unit is given, you have to fill the data. So this is your answer. This is your answer. I hope you understood. It's simple only, because based on this true airspeed and equivalent airspeed, I think more than 3 problems you have solved, or maybe this is the third problem. In gate, I told you in gate problem many times it is happening like a similar kind of the problem they are asking, but the different data. Not data is, or question is what, not going to repeat 100%, but yes, concept will be repeating. Okay, that problem is done. Now this is the another problem. Check. This is problem number 43. Okay, so we'll write the given data. See, a pitot probe on an aircraft in a steady level. Okay, so just think. Hmm, yes or no? So for this aircraft, okay, they said pitot probe is used to anywhere. I mean here or here. Suppose this is the pitot probe. Okay, how it works? It works like this is the pitot probe. You can. It works like a small hole. So this small hole will measure static pressure, and here at this point we will have total pressure. Static pressure, okay. In probe, small hole will be there, and in that small hole, okay, static pressure will be measured. At inlet we will have a total pressure, that is the pitot probe, no? Total pressure. All right, hope you understood this. Many places I think that diagram you have seen like this, no? If you remember, this is the probe. So if you draw exact diagram, it comes like this. So this two section you may have, okay. So inside section here, you may measure total pressure. So here it will indicates total pressure, and these are the small holes. It will measure static pressure. I hope you have seen somewhere in your lab or something. So here you may have PS at this place. PS. Hope you understood this diagram. So they have given data. We'll write the data. Okay. So level flight records this and static pressure. See both pressure they have given to you. Hmm? So P naught. This is what P naught. So we'll write this value. P naught. It is given how much? Let me write this. 55,000 Newton per meter square. And static pressure also it is given how much? It is 45280. All right. Hmm? All right. And density also they have given 0.6, and density is 0.6 kg per meter cube. Very good. The wing area and lift coefficient they have given. Wing area is 16 and CL they have given 2. Okay, these are the given data. The wing loading, which what is wing loading? That weight of the aircraft per unit wing area or wing planeform area means W divided by S. That is wing loading. So we need to calculate wing loading small w is equal to capital W divided by S. For that reason they have given S. So anyhow you have to calculate weight. CL they have given so that you can calculate lift if it is required. See it is steady level. If it is steady level then your problem will be easily solved. So pitot probe on aircraft in steady level flight. Okay. So steady level flight means L is equal to W. So anyhow, if you calculate L, so you may get W. So what will be the lift? Check. Lift force will be L is equal to half rho V square S into CL. CL is given, S is given, density is given, velocity you have to calculate. Okay, so we'll calculate velocity. We'll calculate how you can get that velocity. Check. What is the total pressure? Static plus dynamic. Yes or no? Static plus dynamic. So what is the total pressure here? We can write P naught is equal to static is PS plus dynamic is half rho V square. So from here you can calculate velocity. Simple. See, all problems are very simple. Only the thing you need to practice well. That's all. Half rho V square. So what will be the V? It is check. It is nothing but P naught minus PS 2 divided by rho. We just keep all the value 2 in bracket. What was the value? 50,000. How much it was? 55,000 and 45 to 80. Okay. It is nothing but 55,000 minus, it is nothing but divide by density. What is the density here? Density is 0.6. Density is 0.6. So let me calculate this value. Just wait, give me time. So I will calculate this. Okay, it is exactly 180 meter per second. You also check the calculation. Okay, you also check the calculation, maybe calculator mistake from my side, but you please cross check this. Done. Now lift you can calculate. Lift is equal to weight. As I said, this is the steady level condition. For steady level, okay, for steady level, see steady level, L is equal to W. Okay, L is equal to W for steady level flight. For steady and level flight. So you can get L is equal to W. What is the L? Half. Rho is nothing but 0.6. V is nothing but 180 square, half rho V square into S. Into S is 16 and CL is 2. S is 16 into CL is 2. So what is the weight? Let me calculate this. This is 1 by 2.6, 180 square, 16 into 2. Okay. This is nothing but 311040 Newton. Alright. So now what is wing loading? It is denoted by small w, weight of the airplane divided by wing area. So what is the weight? 31104. Let me check. 311040 divided by what is the area? Area it is 16. It is 16. If you do the calculation, so wing loading will be weight wait how much? 3111040 divided by 16. Okay, 19440 Newton per meter square. Wing loading denoted by small. This is the answer. So you can write, I think it is fill in the blank, na? Check. So here you can write 19440 Newton per meter unit is already given, so you fill the data only, that's all. So this is the answer. I hope it is clear now. Sorry. Okay, this is the another problem. Problem number 48. Check. Gross weight of an airplane. So weight is given how much? 7,000 Newton. Wing area is given how much? 16 meter square. Maximum lift. Okay, when maximum lift coefficient will be given, it means it is related to stall speed. How much it is? How much it is? 2.0. Assuming density at altitude, that density is also given 1.23 kg per meter cube. All right. The stall speed. Oh, right. They have asked the stall speed. What is the stall speed for the aircraft? Simple. So stall speed is the minimum speed required to sustain the flight. Okay. For any airplane to maintain the flight condition, whatever the minimum speed required called stall speed. This stall speed is nothing but minimum. I will write here minimum speed required to airplane to maintain or sustain flight condition, to sustain flight condition or flying condition. Okay, flying condition, better to say flying condition. To maintain the flying condition, minimum speed required to the airplane called stall speed. So how you will calculate this? It's simple. You just write what is the formula. Lift is equal to weight, sea level, and steady and level flight. L is equal to W half rho V square S into CL. So weight they have given to you. So what will be the speed? It will be 2W divided by rho S into CL. So if I'm asking, this is, I said minimum speed is the stall speed. If I said minimum speed is the stall speed, so if it is minimum, see, weight is constant, not going to change, density is constant, area is constant. So to get minimum speed, what should we have? We should have CL max. Hope you understood now. Hope you understood why I said stall speed is the minimum speed. All right. So you calculate this. Keep all the value 2 into 116 to 1.23 into 7000 rho 1.23. What is the area? I forget. 16 and 2. 16 and 2. These are the values. If you check how much you may get, all the value if you keep, it is nothing but 2 it into 7000 divided by 1.23 divided by 32, no? Root. Rho S. Wait, I think I have made mistake. 7000 into 2 to cancel out better. 7000 divided by 1.23 divided by 16. If you do root 18.85, it is nothing but 85 85997 meter. This is also fill in the blank, I think. 18 point, you can write up to 2 decimal. So it is 18.85. This is your answer. So I hope today whatever the problems I have solved, it was from GATE 2018, and whatever the explanation I have given, hope you all understand. But still any kind of, or any small, even if it's very small doubt also, if you have in your mind, you please drop that message in chat box, in comment box. Definitely I will reply. I'll give the solution, another solution also, if you want possible solution, I will give that. Okay, so thank you all.